turn of the body in circular motion, the angular distance is going to be 2 pi radian. But then we know the linear distance will be the circumference of the circle, and that's going to be 2 pi r. Example 1, a body undergoing circular motion makes 4 complete cycles in 5 minutes. First off, if the radius of the circle is 10 meters, find its linear velocity. So we're going to solve this one together. It's actually very simple. So the question says, a body undergoing circular motion makes 4 complete cycles in 5 minutes. Now, this complete cycles talks about the angular distance. So we're going to say theta equals 4 times 2 pi radian. Are you getting me?
Yes.
So how did I get this 2 pi radian? This 2 pi radian is because one side is 2 pi radian. Alright?
Okay, sir.
So one cycle is 2 pi radian. So if it goes 4 complete cycles, then the angular distance is going to be 4 times 2 pi. Now what is the time in the question? We have the time as 5 minutes. We're going to take the time to seconds.
That should be 300 seconds.
So that's 300 seconds. We have it as 300 seconds. So from here, I'm able to get the angular velocity. So omega equals theta over t. So what do I have now? That will be 8 pi over 300, right?
Yes.
So what would that give us in decimal? 8 divided by 300. What do we have?
0266.
0.0266 radian. That's pi radian per second. Alright?
Okay.
So we are just leaving an answer in terms of pi. We can decide to let's just leave it in terms of pi. So since we have got the angular velocity, we can now find the linear velocity. So linear velocity v equals what? Omega r. Right? We're just saying that velocity equals omega r. So what do I have here now? This gives me omega is 0.0266 pi. Pi is part of the number. Pi is not the unit.
Oh, okay.
So it's part of the number. So 0.0266 pi times the radius is 10 meters. So that will be times 10. What do we have here now? 0.266 pi. So the value of pi in your calculator, let's see.
0.835.
0.835 meters per second. So that is the linear velocity of the body. An object is wound in a circular path of radius 30 centimeters if the linear velocity is 45 centimeters per second, calculate the time it takes the body to cover an angular distance of 5/12 pi radian. Now, we have the linear velocity as 45 centimeters per second. That's V. Again, I would like to convert this one to meters per second. So that's 45 centimeters per second. If I take it to meters per second, I'll get 0.45 meters per second. Okay?
Yes.
Alright, so we have got R and V. It says calculate the time it takes to cover an angular displacement or an angular distance of 5/12 pi radian. So you're given theta. Theta is the angular distance, which is 5/12 pi radian. So you're looking for time. So this question is pretty easy. It's pretty easy.
Okay. So it's just taking a longer time for me to understand.
What?
It's just taking me a longer time to understand than.
Okay. That's why I'm going through it again. So the first thing you need to do is to bring out the parameters you need. You have the radius in the question. You convert it to meters. You have the velocity, the linear velocity, convert it to meters per second. Then you are given the angular displacement or the angular distance as 5/12 radian. So now you're looking for the time. So what do we do from here? First thing, I'll need to get the angular velocity. So I'll say V equals omega R. Are you there?
Yes.
So I'll say V equals omega R. Then I can get omega from here. Omega will give us V over R. And that will give us what? 0.45 over 3, sorry. So what that give us? 0.15, very good, 0.15. You must put the units. 0.15 radian per second.
Okay.
So angular velocity is in radian per second. So with this angular velocity now, you go back again and use the second formula for angular velocity. Angular velocity is theta over time. Okay?
Okay.
So angular velocity is theta over time.
Okay.
So you're given theta here as 5/12. You know the angular velocity, so you can find time. I'll just make time the subject. The time gives us theta over omega, right?
Yes.
So time will give us theta over omega. So putting our values, we have theta already as 5/12, then divided by omega, which is 0.15. So finish it up from here. You bring in the value for pi. and you give your answer in seconds. So T becomes what? 8.7
seconds.
8.7 seconds. All right, so that is the final answer. An object undergoing circular motion covers an angle of 3 pi over 4 radian. Okay, let's say an angle of 120 degrees in 2 minutes. So, if the linear velocity is 22 meters per second, calculate the radius of the path. So first you have theta equals 120 degrees. You convert it to radian. How do you convert to radian? You multiply by 2 pi over 360. Are you there?
Yes.
This is what you're going to do by when you convert it to radian. You do times 2 pi divided by 360. Then you have the time as 2 minutes. You convert it to seconds.
Okay.
So omega is theta over t, okay?
Yes.
So from here, you can get omega, then you now say omega equals v over r, then r equals v over omega, okay?
Okay.
So from here, you know the v already, and you've already